And we're live, sort of. This was supposed to be a live event. Apologies, everyone, that it's not, and we were uploading this after the fact. This is Office Hours with an Engineer, a ongoing series from ARM TresureData, where we do technical deep dives with the engineers engineering the future of CDP and making tomorrow possible. Today, we're going to be talking with Taro L. Saito, the author of the Airframe RPC framework. We're going to do a deep dive on that. So I'm going to go ahead and throw our wonderful faces up on screen now so you can see us. So hi, everyone. My name's Austin Blackstone, Developer Evangelist at ARM TresureData, and this is Chico Shokai.
Yeah, I'm Taro Saito. Yeah, nice to meet you. I'm an engineer on TresureData.
Awesome. So today we'll be talking about Airframe RPC. Just to let everyone know, we are live streaming this on YouTube, or at least we're supposed to be. In theory, you would be able to put your questions in the question box down below, and they'd show up on screen, and then we'd take Q&A after the event, and we'd have a live Q&A session. The goal of these office hours is to provide you direct access to the engineers at TresureData to ask your questions about engineering and the future of engineering. If you have any questions, please do put them in the question box, and whether you're live with us on the event or post-event, we'll do our best to answer them in a timely manner. That said, if you have any big questions, please do save them for the end, because there's about a 20-30 minute presentation period, and then 20 to 30 minutes of Q&A at the end. So that said, without further ado, let's go ahead and get started. Taro, if you would share your screen, we can kick it off.
Okay. So, do you see my screen now, or are we ready?
We're ready. Please share your screen.
Okay. Okay. Do you see my screen now?
We can see your screen.
That's nice. Okay. Then I'll talk about Airframe RPC. I'm Taro. I'm Principal Software Engineer of ARM TresureData, and PhD of Computer Science. So my work is building customer data platform for TresureData so that our customer don't need to build their own platform by themselves. We are helping customers for doing customer data analysis. And I've created Presto as a service for TresureData. Presto is a distributed SQL query engine, which is now processing over 1 million SQL queries every day on the cloud. And I'm doing a lot of open source work. One of them is Airframe, which will be talked today. Another thing, interesting open source library I created is SnappyJava, which is a compression library used in Parquet, Camera format, Spark, and so on. A funny thing about SnappyJava is it's used by many companies like Netflix. So, for example, if you watch a Netflix movie, then your access log will be analyzed by using my code. Then Netflix doing a lot of analysis for improving your experiences on watching movies. So I'm contributing indirectly part of your life. So this is a really funny thing about interesting thing working at open source project, and I created a lot more open source projects. But today I'm going to talk about Airframe, which is core Scala modules of ARM TresureData, so which is a collection of Scala-based open source software assets about knowledge, production experiences, many design decisions. These are packed into a single module, single project. Actually, Airframe has more than 20 common utilities for Scala, including logging, object serializer, JSON parser, dependency injection libraries, and so on. Something directly related to TresureData is Airframe Fluently. Fluently is an open source project created by TresureData. You can send metrics to Fluently. Fluently can redirect your log message to anywhere. So including TresureData So Airframe Fluently is a module for helping sending metrics to Fluently or TresureData. Airframe RPC, which I'll talk about today, is a HTTP service builder. I also talk about the same thing, Scala Matsuri conference, which will be held at Tokyo. Unfortunately, this time the conference will be totally online, but then on October 2020, I'm talking about more and more about Airframe RPC. Another thing, Airframe has Airspec testing framework for Scala. I also talk about this Scala Days conference, which will be held Seattle, hopefully next year on May. Then why we needed this kind of library? This is because CDP platform is actually built around many thousand machines. We definitely needed help for efficiently building code for managing a lot of machines, instances. So this screen shows the number of instances we are deploying on production or various sites, regions. We have many hundreds of services. We are managing thousands of instances. These services are communicating using HTTP protocol, which is exactly the same technology we are regularly browsing web pages using web browsers like Chrome, Microsoft Edge, or mobile devices. So not only browsing web pages, we are using HTTP everywhere for communicating between services. So this graph shows the communication interaction between multiple services inside TresureData CDP platform. So simply having this number of communication is really challenging. But the engineer who need to write code for making these communication having a lot of challenges for managing this kind of code. So challenge is we need to make it easier for working or communicating with remote servers. RPC, which is a remote procedure call, is a technique for making it simpler. So RPC is a technique for making remote function call as if they are local functions. So if you write a program, calling a function defined inside the same program is very easy. You just need to write a function, then your program will call the function and getting a returned response. But if you need to talk with remote servers, remote function call involves many intermediate components like HTTP client, HTTP server, and also data also need to be serialized so that we can transfer the data through the network. So yeah, your program, you need, if you want to make a remote call against remote function, so your program need to ask HTTP client to serialize your request object. Then your request data will be transferred to a remote server. So request data usually has some binary format or JSON-based data format can be used frequently. Then server receives the data and server will be responsible for deserializing the data to invoke the function registered as the remote server. Then function will return the response. But server also need to serialize response data so that we can send data through the network. Then client need to deserialize so that the program can understand the data. So there are many intermediate processes that will be involved if we need to make remote function calls. So there are many approaches for implementing RPCs. The traditional approach is defining REST APIs. The REST API is defining function interfaces by using standard HTTP methods like HTTP GET method or HTTP POST method and so on. Then you need to design resources, web resources using HTTP paths. Like if you want to provide a user's profile data, then probably you may encode your request like /user ID one's profile or /user two's information, something like that. So you need to define out of HTTP path and how to encode your data to HTTP message body. So that has been used widely for a long time. Another approach, which is open source in 2015, was GRPC. So GRPC can define function interfaces by using Google's protocol buffer technology. Protocol buffer is a language, another sort of programming language to define data shapes and also RPC method interfaces, something like RPC get user profile. This RPC method will take user profile request data structure, then returns user profile response data structure. So protocol buffers can be used for defining these function interfaces and model classes request and response data structures. Then by following this definition, GRPC or protocol buffer generates server and client called stubs. Stubs is a base implementation for defining your own service and client from protocol buffer files. So it's Google's own technology, but it's open source 5 years ago. Then many companies start using it for efficient RPC core implementation. Another approach is Open API. This is very similar to REST API, but you need to define REST API interface using YAML or JSON. Then Open API generates the server and client code. But yeah, generating code part is really implementation dependent. So there are many, a lot of technology we need to learn if we use Open API. So actually, there are many sort of religion laws. What is a good API design, or what technology we should choose. So the article posted on Google's developer blog explains really well what is the pros and cons of REST API or Open API or gRPC. Actually, so this post is written by Google, so you need to read it with grain of salt. But basically, this article is a fair comparison of what is good about REST and what is good about gRPC. For example, some downsides of REST and Open APIs are designing really good APIs over HTTP requires significant amount of time and experiences. So actually, even inside TresureData, we are using a lot of REST APIs, but some REST APIs are well not designed. So we are struggling with performance issue, or making change can be difficult if we design poorly some REST APIs. So yeah, but good thing is if you have really good engineer, actually our backend team engineer has many experience of designing good REST APIs. So then this kind of people can design really clear REST APIs or using Open API. Then yeah, we are really comfortable in using that. But yeah, using REST API or designing good API really needs expertise of design experience. Well, gRPC, gRPC is smart if you are inside the ecosystem, but the downside is it requires many special software like code generators using protocol buffers. So if you are comfortable in using these technologies, you're okay to use it. But if you are not already using it, then you need to transfer yourself you need to jump into a different ecosystem. So it has many these obstacles to overcome. But yeah, what I want to say here is after overcoming these disadvantages, both approaches works really well. But our real problem is we just want to make RPC call at ease. So I created a totally different approach. So this new approach, Airframe RPC, is use Scala functional programming language as a unified RPC interface. So once you define your RPC interface using Scala, you can implement RPC servers or RPC client just by using the same Scala interface. You don't need to use protocol buffers like GRPC. But good thing about Airframe RPC is backend server is really pluggable. So you can use HTTP1-based web server like Finego. Finego is open source HTTP server software created by Twitter. And also you can also use GRPC backend for implementing your RPC services. So so why using Scala is good for RPC? It's because Scala is a functional and statically typed programming language. Actually, this is a perfect fit to implementing RPC services. For example, if you want to define RPC methods, you can just use Scala functions. For example, this is an example API definition, RPC definition of Airframe RPC. So, but the syntax is just Scala. So thread is a sort of interface in Scala. Then diff means function definition. So hello is a function name. So this function hello receives one function argument, person, then returns a string response. A good thing about Scala is also object-oriented programming language, which is statically typed. So this person object has really nested data structure. Like person has two fields like ID and name, and ID has an integer type and name has a string type. So you can describe function definition and data structure including its types by just using Scala. So there's no difference. You don't need to introduce another language like protocol buffer. You just need to use Scala for defining RPC function interface and data types. You can use arbitrary Scala's primitive types like integer, string, float, double, array or map, so it can be supported by using case classes. Case classes of Scala is a handy syntax for defining this kind of simple data structure. And there are many strengths of using Scala. Scala can be used for high performance server applications for backend programming. Scala is a JVM-based language, so we can leverage existing JVM ecosystem like, even GRPC can be used. GRPC Java is written in Java, but we can easily use it for implementing RPC on Scala. And also, there are many good web server libraries like Finego, Arca. We can leverage these existing technologies. Scala can be used even for front-end programming. Front-end programming usually means application works on browser or mobile devices. A good thing about Scala is Scala has a Scala.js, which can compile Scala code into JavaScript, which works in modern web browsers like Firefox, Microsoft Edge, and Google Chrome. In 2020, Scala.js finally became a stable version. Then after 7 years of development, which is now totally comfortable to use, it can write really advanced web interface by using Scala.js. So let's think about how to build RPC framework on top of Scala. So here I showed various building blocks that are necessary for building RPC services. First, we need a language for defining function and request and response data structures. For example, REST API uses HTTP paths for defining functions and JSON messages for request and response data structures. Protocol buffer, using GRPC uses protocol buffer itself which has RPC function definition and data structure definition. In Airframe RPC, we just use Scala's functional statically typed language interface for defining RPC service. We also need message serializer and the serializer for sending request and response objects to the network. We also need network data format like JSON or protocol buffers. Airframe RPC uses Messageback or JSON for sending the data to the network. Additional thing we need to have is HTTP client, HTTP server implementation. So actually, just for calling remote function, we need a lot of things to consider and develop. So here shows how Airframe RPC encodes request object by using Messageback. So Messageback is a compact binary format which is compatible with JSON. So here is an example Messageback data. So the same data represented in JSON and Messageback can have really defined data sizes. So in JSON, we need to encode this data by using 27 bytes. But if we represent the same data using Messageback, we only need 18 bytes. So compared to using JSON as is, converting JSON into Messageback is much more efficient. Sending this smaller data can be much faster. So Messageback usually encodes a complex structure by having a type prefix first and the size. So data itself is very small, but the good thing about Messageback is it has primitive type encoding, like 2 can be encoded into C3, 0 can be just 1 byte representation. So there are many smart compression technologies inside Messageback format definition itself. So we can use Messageback. Then what we are going to do is encoding arbitrary object written inside Scala's program or Scala.js program using Messageback or JSON, then decoding it into the original object form so that we can pass the same object to remote servers. So that's the problem. So to do so, we created the framework interface for encoding and decoding data through Messageback, which is called FMCodec. FMCodec has a MessageCodec interface, which has 2 methods, pack and unpack. The pack is converting arbitrary data into Messageback, and unpack is the opposite, converting Messageback data to data. So by combining multiple message codec, we can convert arbitrary data format into different formats. So that's a good interface for good thing of the good advantage of Messageback using Messageback. By using Messageback as an intermediate data format, we can translate arbitrary data format through message codec interface. So to enhance this functionality, we defined a lot of predefined codecs inside Airframe codec module of Airframe. It has many primitive codecs: byte codec, character codec, short codec, integer codec, or floating value codec, string codec, Boolean, timestamp. And also complex data object can be encoded into Messageback by using array codec, sequence codec, list codec, and so on. There are also many other Java-specific codecs. So by combining these predefined codecs, you can serialize even complex object like this. This data object class A has 3 parameters, integer, string, doubles. By combining codecs for individual parameters, we can convert this complex object into message form pack format. Then we can create a really simple interface for converting arbitrary data. For example, message codec of A type can, for example, unpack this kind of JSON data by using Messageback. Then you can get the original object of this form. Messageback is almost compatible with JSON, so you can use unpack Messageback or unpack JSON if you want to convert data into Messageback from Messageback or JSON. So we can extend this approach even for encoding function calls. Function calls basically have method name and argument parameters, argument values. So then if we encode this method call, the argument can be map structure of person. Person is a function argument name, and complex object can be represented like this. Then this map structure will be represented in JSON or Messageback to form this, to construct this kind of sequential data format. So we can send this JSON data or Messageback representation of this JSON data to the network to invoke a function in the remote servers. So Airframe RPC, just need to have this RPC annotation on your interface. Then you need to implement actual code for returning the function response. You just need to extend this interface to implement your own implementation. In this example, it just returns the person's name and person's ID by adding hello string. Then that's it. So by using this implementation, you can start an RPC server, which can be a Finagle backend. So you first need to define a router definition by adding actual RPC implementation. Then with this short syntax, Finagle server with router and port number 1880, you can quickly start a new RPC server by using Airframe RPC. So Finagle is treated as HTTP server written in Scala, which is HTTP 1 based. A good thing about using it is it's also accessible from web browsers running Scala.js code. So you can create an RPC interface between web browsers and web servers. Airframe RPC also supports GRPC backend. GRPC is HTTP2 based protocol, so unfortunately it doesn't work with modern web browsers, but it's really efficient because it can multiplex a lot of requests into the single connection. According to our benchmark, it's 3 times faster than Finagle HTTP 1 based protocol. So we extended GRPC to support Messageback format. So GRPC, most of people think GRPC is for protocol buffers, but GRPC itself is a really data format agnostic framework. So we can use arbitrary data format, not only protocol buffer, but also JSON or Messageback. Then, similar to Finagle-based RPC, we can just create a GRPC server by using GRPC server syntax of Airframe. So this is a little bit more detail about how to extend GRPC if you're interested. So in order to support Messageback in a GRPC, we have 2 extension points of GRPC. Currently, we are using GRPC Java project. What we need to extend are method descriptor of RPC definition. So you can set arbitrary request marshaller and response marshaller. Marshaller is a serializer or the serializer. So you can, when defining RPC endpoints using GRPC, you can set your custom marshaller. Then we are creating our own Messageback-based request response marshaller like this. Then create a GRPC endpoint definition. So only by using this kind of simple extension, we can support GRPC inside Airframe GRPC. Then we are going to generate RPC clients for accessing RPC servers. So SBT Airframe Plugin is sort of compile time program that will read RPC interface classes defined in Airframe RPC and generate client code for the target platform. So we can generate regular HTTP client or gRPC client we can also generate client for Scala.js so that we can use RPC client inside web browsers. SPT Airframe also supports generating open API specification in YAML format. So theoretically, we can create cross-language RPC clients if there is a open API-based client, HTTP client generator in some open source. Then there are final things. So we just need to make an RPC call. So we need to create an RPC client, which is generated by SPT Airframe Plugin. Then you can make your first RPC call. Client my service hello, then passing person data object. Then the data internally, it will be serialized into Messageback. The server will unpack the Messageback data into the person object. Then function is evaluated. Then it will be again encoded into Messageback. Then client with the Messageback. Then pass it into the program. But this program doesn't do this kind of detail. Actually, programmer doesn't need to care about these internal details. You just need to make a function call, which is defined in the RPC interface. So the Airframe RPC framework takes care of the rest. So that is a really nice thing of having RPC. So yeah, at the time probably I should show some demos. This is an example of defining RPC interface by using Airframe RPC. So this API has a hello method, which just returns the request sent name to the client. Then we can create a GRPC server like this syntax. Then the client, we need to initialize some GRPC channel, but after that, we just need to create a client and making an RPC call. Then yeah, client can receive the response. I'm sure I can show you the screen, but yeah. So yeah, this is an example of launching GRPC server. Then, so GRPC server just started. Then we can make a call to the server. The server sends several messages to the server. Server received several messages and return to the client. That's it. So, but yeah, the amount of code I wrote is like this. So it can be fit into the single page. Here is a quick benchmark result. So the question is how many RPC calls we can make in a second. By using GRPC backend, it can be 32,000 RPC calls per second on my local machine. I compared various settings like by using Finego, asynchronous call, synchronous call, or GRPC's asynchronous call, synchronous call. So basically, yeah, GRPC is 3 times faster than Finego, which is based on HTTP. This is mostly because GRPC has an optimization for multiplexing many requests inside a single connection. So we can pack many requests inside a single connection. So I think that's the major reason why GRPC-based backend performs better. So here's a summary of Airframe RPC. So Scala can be a unified interface for defining RPC. We can build full-fledged RPC services based on Finego or GRPC. It can also work in Scala.js for developing web application. So for more details, you can visit weWait.org Airframe website to see more details. So that's it. Austin.
Alrighty then. So at this point, we're going to move on to our Q&A section. So if you can stop sharing your screen, I will go ahead and get us over to that. So this is the point in the live stream where we would be taking Q&A from the audience. You can put your questions in the chat box down below and they will show up right over here. That said, as you can see, we had a couple announcements right as the stream was getting started for this one. We were not able to actually start the live stream, so we are recording this locally. So I have a preset series of questions that we're going to go through. In future events, you will be able to ask live Q&A. Likewise, if you're watching this video after the event, as all of you are, please do ask us questions in the comments section down below this video, and we will do our best to answer them in a timely manner. So that said, I'm going to pull up my set of questions here, and we can go through them.
Okay.
So the first question that I've got for you is, what is your pitch for developers that are currently using Java, Python, or JavaScript? These are the top 3 languages on the GitHub language survey. Scala isn't even the top 10. And given that Airframe RPC is written in Scala for both front-end and back-end, and I can see the draw of doing that, so it's unified, why should the existing Java, Python, and JavaScript engineers who are really deep down in their stacks consider switching to using Airframe RPC?
Yeah, it's a really good question. It's always difficult to answer this kind of question because, actually, programming language is a language everyone should use. So you don't need to stick to a single language because if you want to write a code in Java, it's okay to keep using it. If you really like Python, it's really good. But the real problem we are facing is not so many people using Python. We not write framework or high performance web application servers. So even inside Java engineers, people who actually need to write cloud platform like CDP is not so many. So regardless whatever language you are using, the number of people who actually need to write a framework is really small. So yeah, we always need some interface between the languages. So why GRPC is good is GRPC is a sort of lingua franca of Google inside Google. Google also uses many programming languages inside the company, so they need a common description of the language, a common description of the RPC interface or function definitions. So their choice was using protocol buffer, but so that internal engineer inside Google can use the same language, same model classes for communicating each other. But yeah, currently most of our services are written in Scala, internal ones. Some of them are public ones, but we don't always need to communicate each other. So Airframe RPC currently is focusing on improving the productivity of engineers who need to build cloud data platform. So there's a timing. If you really need to write backend programming, then core components or cloud data platform, then Airframe RPC using Scala can be really a good choice. But until that moment comes, I think you can stick using your own preferred language. So that can be my answer.
That's a solid answer. My next question for you, and I think you kind of answered it, but I'm going to draw it out in a little bit more detail. Who is the target audience for your framework? Is it those who are looking to simplify, those who are looking to build a new service that's easily scalable and quick to build? Who's the main target?
Yeah, actually, so the target is, the first target is TresureData engineer. So, for example, when building web services, we needed to design good REST interfaces so far. So there are many design rules even inside the company, which framework we should use, which REST API we should define, how to encode each functions into HTTP endpoints. So there are many discussions to create a good design. But by using Airframe RPC, we can totally skip this kind of complex discussion. We just need to define RPC interfaces just by using Scala. Then you can create RPC services at least. So Airframe RPC create a shortcut to start building interfaces for communicating between services. Yeah, so that's the primary target. Yeah.
Sounds good. That makes sense. So people who are having to maintain large complex services are the first audience because it makes it easier to maintain them and easier to extend them, it sounds like. Okay. What are the three big features that you're working on next to add to the framework?
Okay, I have additional slides to show these things. So can I start sharing my screen again?
Sure.
Okay.
And as soon as you share your screen, I'll switch us over. There you go.
Yeah, actually, there are many additional things. So what I recently added to Airframe is reactive streaming interface, so which can be used for Scala.js development to create interactive web application, front-end application. So as you receive a new event, then it will rewrite your web pages interactively, which also can be used for gRPC server streaming, client streaming, bidirectional streaming. So gRPC, good thing about gRPC is it has a better support of server streaming, client streaming, and also bidirectional streaming, so that server and client program can interact each other at any timing. So RX reactive streaming abstraction can be used for implementing this kind of services. And also by using this RX interface, we can create really interactive interfaces by using Scala.js. This is an example of our Presto's query monitor, which shows the currently running query and its historical query stats in the same string. These things are displayed interactively as you check some queries. So which is totally written in Airframe RPC and Scala.js. So by using Airframe, we can create this kind of service. So I want to enhance these features so that we can more easily create such user interfaces. So these things are really the next improvement.
Okay.
Big things.
I'm honestly looking forward to this. This makes me really excited.
Yeah.
What, the next question for you, what are some tangible improvements that we've seen by using Airframe RPC at TresureData? Have we seen
Mhm.
like quicker turnaround, just greater developer happiness? Because I know personally when I've had to do backend work, some of it can be a great
Mhm.
joy when it just works, and some of it I can be pulling my hair out for days at a time until something moves somewhere
Mhm.
and I'm still not sure why it works, but it works. So like, what are the
Um,
the tangible improvements we've seen?
Actually, really good achievement I experienced this year is some engineer who just joined to TresureData could write RPC application, server and client, even Scala.js frontend within 1 week. So it was really impossible before, but after developing Airframe RPC, no need to design complex REST API. We just need to define RPC interface using Scala. So if you are already familiar with Scala, then writing high performance server, client, and even web interfaces, interactive web UI can be totally possible within a short time. So that has been one of the tangible improvement I saw this year.
That's incredible. I mean, it took me a good 2 months when
Yeah.
I first joined to start writing my first bit of code that was
Yeah, you don't
actually,
need to spend 2 months. Yeah, you just need 1 week.
man, now I feel bad. I feel dumb. Okay. Sounds good. Um, so where would you recommend, my next question is, where would you recommend a new beginner to start? If they see this video or they read your documentation, by the way, docs are
Mm,
linked down below in the description of this video, so if you'd like to learn
mm,
more, do check that out. But where would you
mm,
recommend someone start if they want to get started with Airframe RPC and either evaluate it or just learn
mm.
more?
Yeah, so yesterday I just created a really small project which can launch a simple Airframe RPC server and client. So please visit GitHub repository of Airframe. There is an example folder which has a really small project. Hello RPC project is contained inside the folder. Then you can start testing it, Airframe RPC, by using this small project.
And you said this was on the GitHub, is that correct?
GitHub.
Okay, and that is linked from the main Airframe page that's linked down below, correct?
Yeah, yeah.
Beautiful. So click in the link description box, check out the GitHub examples in the example folders. That's the place to get started, guys.
Mm,
Um,
mm,
so I got a couple other questions for you. I noticed that you added gRPC support recently, and I noticed that this
mm,
wasn't on the
mm.
development plan for the year when I looked at, what you were planning to do.
Yeah,
What
yeah, yeah, yeah,
spurred the
yeah.
inclusion of it? How did that happen?
Yeah, actually, so GRPC is sort of other people's technology so far inside TresureData because TresureData is using AWS. AWS is not supporting HTTP2 so far until 2019. They launched a service mesh product last year. So most of technology inside TresureData are based on HTTP1, based on REST APIs. So gRPC, yeah, I was looking for how to leverage gRPC, but actually we had no plan in using it. But after developing Airframe RPC, it turned out to be really easy to support gRPC. So I started the development of gRPC backend just this month, and I already finished the first implementation of gRPC backend. Then it already performs really better than Finego-based backend. So yeah, there are many coincidences. Simply I was um, keeping eyes on gRPC technology, but simply I had no opportunity to test it. But yeah, but it was many coincidences and also existing technology stack that makes possible to support gRPC. So uh, the next step will be testing gRPC inside some production environment inside TresureData so that explore the benefit we can get by using faster RPC backend.
Ooh, interesting. So the potential exists if you have an existing gRPC service in your
Mm,
existing deployment that you could see
yeah,
increased speed or other benefits to switching the underlying backend to using Airframe while keeping your
mm,
actual transmit format intact. That's interesting. So that
yeah,
could be a thing worth
yeah.
trying. I look forward to the benchmarks.
Mm-hmm.
So I got another question for you. I noticed that you've got MessagePack in there. Can you speak at
Mm,
all to So I came from the IoT world, and we used MessagePack or
mm,
lightweight M2M encoding and things like that because we had constrained bandwidth. Mostly for
mm,
the consumer data platforms, bandwidth really isn't much
mm.
of a concern. But can you speak to the performance implications of using MessagePack, both on the transmit
Okay.
and the receive side and the overall infrastructure, and
Mm,
potentially cost of savings for smaller transmission sizes
mm,
when
mm,
relating to infrastructure costs?
mm. Yeah, so actually, if you have ever used JSON, then using MessagePack can be a really just a simple replacement for faster side. So, for example, MessagePack can be compact alternative of JSON. So also the format is almost compatible. So if you already have some JSON-based services, using MessagePack should be very easy. Yeah, so performance is really good. And also MessagePack is a self-descripting data format, which means types of the individual data elements is already encoded inside the format itself. So you usually don't have any trouble in converting MessagePack data into, for example, Scala object or other data format. So this is called schema-on-read technology of MessagePack. So uh, TresureData itself is actually MessagePack database services. So many backend storage are encoded inside in MessagePack. We are always converting message data into, for example, SQL query result types or external data sources format, like by using Embark, Fluently. So MessagePack is used everywhere inside TresureData. So yeah, when developing FM RPC, I thought, yeah, using MessagePack for RPC would be a good fit. And actually it was. So yeah, and it also makes simpler defining RPC interface and also creating a schema-on-read codec, better object share relation using MessagePack. Then yeah, fast performance, as we saw in the performance result, performance is not so bad. We can make more than 30,000 of RPC calls per second. I don't think there is much overhead compared to much compact protocol buffer binaries. So yeah, but yeah, having a visit comparison might be better or might be interesting.
Cool. I look forward to seeing those benchmarks eventually.
Yeah.
Final question for you as we're coming up to our time here. I did promise you a 1 hour thing, so we're kind of coming up at 50 minutes. So final question for you. What do you see as technical challenges facing the enterprise software as a service space in the next 2 to 5 years from a technical perspective? Not really strategy or marketing, but just engineering wise, what do you see as the next challenge that's coming? And how do you think Airframe can help solve them?
Okay, I think there are two answers for that. So one important thing is how accumulating experience of developing distributed systems. So yeah, even though Airframe RPC abstract away details of message transfer between server and client, we still need to tackle various troubles like network disconnections or service failures. So to overcome these things, we also need to have robust retry mechanism of collection or throttling requests so as not to overkill remote servers. So many technologies are necessary for implementing distributed systems. So key challenge is how can we accumulate knowledge, workarounds, experiences into our code. So Airframe is an approach for helping that part. So Airframe has many modules created based on our experience of building distributed systems. So even simple HTTP client call has good security protection like retrying or request throttling is already implemented inside Airframe HTTP client. Then users or developers who are not yet familiar with these troubles can benefit from previous learnings. So accumulating knowledge is a key part, one of the key part. The next thing, for example, upcoming 2 or 3 years, 2 or 5 years, the next movement will be how to leverage more faster microservices movement. So as I showed you, we have many hundreds of services working internally, but managing them is not so easy. So sometimes it's really painful. Even deploying new types of code is really challenging. So there are many movements on the world, like introducing Kubernetes or introducing service mesh so that we can abstract service discovery or failure handling or rotating migration. These things are dumped into the external framework, right? So Istio, Kubernetes, there are many frameworks so that reduce the burden of engineers who need to deploy thousands of services. So I think we need to be prepared for that direction. So I think for upcoming years, we need to face these challenges. Even managing the current CDP services, we have many challenges. As we have many components, testing between components or integration test is becoming hard. So we need some help for making this testing efficient. Yeah, I think these are my answers.
Those are some solid answers. With that, folks, my apologies again that we couldn't get the live stream working today, but if you have any more questions you would like answered by Taro or myself, please do leave them in the comments down below this video, and we will get to them in a orderly time frame as soon as we can. Between the Tokyo office here and the Mountain View office out there, we'll get to them usually within 24 to 48 hours. So that said, thank you everyone for coming and being here with us today. We really enjoyed having you here. Please do share this around and look forward to more of these videos coming out on our channel. We are trying to get a regular office hours series started and going. So if you'd like to connect with us, you can find us on the social medias displayed on screen now. We, of course, have the obligatory Facebook, YouTube, GitHub, LinkedIn, Twitter. I've also left my personal Twitter up there, so if you want to reach out as the developer evangelist for TresureData, it is my job to be the public face of this. So if you have any questions, please do let me know. Likewise, down in the description box down below this video, you'll find a feedback form. Please do consider filling that out. We need your feedback to make these events better in the future. If there's something you liked, if there's something you didn't like, if there's something you'd like to see in a future office hours video with the engineers, please let us know. We do read those and it does influence the future of the video series. So without further ado, thank you so much for coming out today. We really appreciated having you. Have a great day and we'll see you in the next one. Bye now.
Yeah, thank you for having me. Bye.
My pleasure. Have a good one, guys. Bye.